Good.
Bottom and then pull out same.
Good. So factor the top, factor the bottom, restrict first, then divide, right? So the bottom is 2 perfect squares, so we factor to be x plus 2, x minus 2. Are we excellent factorers in here?
Yeah.
Awesome. So then you'd say restrict first, then divide. So x cannot equal negative 2 for that and 2 for that, right? Then you would divide out exact factors. So then our answer is x over x minus 2 as long as x does not equal negative 2 and 2. Everybody feel comfortable with simplifying? Okay, now right here, when multiplying, these are the steps in our head that we cannot get confused with what we're learning today. The steps for multiplication is, first, factor all the parts. So we have x cubed, we have an x, and then left is x minus 1, times by, we factor that, we get x plus 1, x minus 1, true? And then right down here, we're going to pull out x cubed, then left is x cubed plus 1. Doesn't that factor more? That's 2 perfect cubes. So cube root the front thing, you get x. Cube root the back thing, you get 1. Then we got to do the front times the front. Front times the back times the back. This sign and this sign are the same. The next sign's opposite, the last sign's plus. Okay, now remember, the next step is to multiply straight across, but do not actually multiply. So I have an x cubed. I have an x plus 1 and x minus 1. True? On bottom, it looks like I have an x and an x cubed. X times x cubed. Then I have an x minus 1. Then I have a x plus 1 and then an x squared minus x plus 1. Okay, now restrict, then divide. So my restriction is 0. X cannot equal 0. True? 0, 1, negative 1, and then this would take quadratic formula. No restriction there. Okay. Awesome, start dividing out exact factors. So then left on top was just a 1, wasn't it? Yeah. On bottom we had an x times by x squared minus x plus 1. Okay, with our restrictions. So just remember those steps. Today we're not going to be adding and subtracting rationals. Now remember, when adding and subtracting fractions in general, we just have to get a common denominator. This also takes 10 minutes to have this thing acting up. Okay, so guys, if I said to you 2/3 plus 4/5, you wouldn't be able to do it unless you had a common denominator. So we've got to get a common denominator on these. This is different than multiplication and division. So write down these steps. First, it says, now what's hard is you have to know these steps and differentiate the similarities and differences in them. Because what's hard, what makes it hard is there are similarities that we do to multiplication and division. And then there are huge differences. If you get them mixed up, you're going to get a very bad test score, I promise you. So we've got to know them really well. So our first step is factor the denominator only. That is different than multiplication and division. Multiplication and division, we factor all of it. With addition and subtraction, you factor the denominator only, and then we find a least common denominator. So in my example right here, we do not factor the numerator, only the denominator. So we would have x squared plus x. Then we would factor this denominator, so that would factor to be x plus 2 and x minus 2. Then we have a plus sign. We have x plus 2, and then the bottom x minus 2. Factor the denominators only. Do not factor out the numerator. Then we have to get a least common denominator. So look, everyone, you can only get a common denominator by multiplication. Now x plus 2 is an exact factor. The only way to get an x plus 2 is to multiply by x plus 2, or to, over x plus 2, or to already have an x plus 2. So this one has an x plus 2, this one needs an x plus 2, because that's x minus 2. So we'd multiply by x plus 2 to the top and bottom. Now this one has an x plus 2, x plus 2, x minus 2, x minus 2. Aren't your denominators the same? Yeah, so we can move on to step 2. Now this is really interesting. Multiply out the numerator only. We actually do multiply in this one. So that is different than with multiplication and division. With multiplication and division, we never actually multiply it out. With addition, we have to. And subtraction, we have to. Now we only multiply out the numerator. The reason we do that is because, look, so what I mean by that is we have to be able to combine like terms in the numerator. To do that, I've got to have all this stuff in standard form, right? Otherwise, you don't know what to combine. So we're going to just simplify the top, essentially. So let's do that. Now look, x squared plus x was not changed. So I have an x squared plus x. Now I have a plus sign. Now I got to distribute this stuff out. So that's x squared plus 2x plus 4. So combine like terms. This is me combining the numerator. Because I have a common denominator, I get a common denominator so I can add up my numerator. So now I have 2x squared, don't I? Then I have plus 5x's plus 4. Okay, so that's our numerator, and that was all over. Now that I've combined like terms, I will put back on my denominator, but not until I've combined all like terms. So that was all over x plus 2 and x minus 2. And now we're on our third step, simplify it. So how do we simplify? Back to the top, back to the bottom, restrict, divide. So we could try factoring it. Well, it multiplies to be 8 and adds up to be 5, nothing. So the top doesn't factor, so if that's true, then nothing will divide out, right? So that would be our final answer as long as x does not equal negative 2 or 2. So it's actually easy, as long as you follow the steps and don't get them confused with the similarity and differences of the multiplication division problems. Let's do another one. Following these steps in your head, do you need to take a picture of it? Do you have it written down, the steps? Okay, now I do want to say one thing with subtraction. I know some of you have some misconceptions about subtraction, so looking at this. If I said take 6/5 minus 2/5, you have a common denominator, right? So you could combine the numerator. Now here's the question. I always have people say to me, so we could take the negative. Now they say this when we get to rationals. They say we get to a net, we have a minus sign, so we need to distribute it to the top and bottom.
No.
Now that would make it a plus sign, wouldn't it have? Was it a plus sign? No. So a negative can go on top or on bottom, but not both. So I can choose. I can put this negative on top or bottom, but not both. Now let's think about why it would be smart in this case. Look, we have a negative 5 and a 5. Are they common now? No. They're not common denominators. If I would have put it with the top though, are they?
Yeah.
So I always, always, always put my negative on top. And then look, we would just add straight across so we would get 4/5, right? Awesome. So looking at this problem, you'd say, I have a subtraction problem. I always do this because there's less room for error. I say, okay, I'm going to make this an addition problem. I'm going to take the negative and distribute it to the numerator. Well, that means I got to distribute it there and there. So then I'd be dealing with x minus 2 over x plus 3. Then I'm dealing with a plus negative x plus 5 over x plus 3. And we've already taken care of distributing the negative. And now it's just an addition problem. Then we just get a common denominator and go through the steps. Is everybody good with that? Okay, I'm not going to continue this one. I'm just going to do up to my next example. I just wanted to show you how to distribute the negative. Okay, so it says simplify. You'd say when adding, I first need to factor denominators. When there's one term, there's no factoring. Okay, awesome. Next thing is get a common denominator. So I always start with the lowest number, like 8, and I do 8 times 1 equals 8. Can I make 12 and 8? No. 8 times 2 is 16. Can I make 12 a 16? No. 8 times 3 is 24. Can I make 12 24?
Yeah.
Then let's go with that. All right, let's make those 24. So we times by 3 over 3. Then right here, wouldn't we times by 2 over 2?
Yeah.
And now this one has x squared, so this one needs a x. Okay, now our next step is to multiply out the numerator, right? 3 times 3 is 9, plus sign. 1 times 2x is 2x. Now write it in standard form. So our numerator is 2x plus 9. Now because there's only one term, yeah, this time I am going to actually multiply out the denominator because I'm not distributing anything. So that's 24x squared. Now you'd say, that's my answer, can I simplify? Does the top factor? No. Does the bottom factor? No. Restrict, then divide. So x cannot equal 0, correct? Now nothing will divide out if it didn't factor, so that would be our answer. Pretty straightforward stuff as long as you follow those steps. Okay, so a little bit more of an problem. Okay, so you have x minus 1 over x plus 3 plus x over x plus 2. I always have people think they can subtract stuff to get a common denominator, so they say subtract 1, because then it would be x plus 2. You can't do that. You have to get common denominators by multiplication. So x plus 3 is an entire factor. This one needs an x plus 3. Now right here, you'd say this one has an x plus 3, it needs an x plus 2, doesn't it? Now everyone, look right here. If there's two terms, always put parentheses. So you're on to step 2. Multiply out numerator only. So I'm distributing all this stuff. Focus your eyeballs with me. We have an x squared. Then we have minus x plus 2x, right? So that'd be plus x, wouldn't it? And then we have minus 2. Then we have a plus sign. Then we have x squared plus 3x. Combine like terms in the numerator. So we have 2x squareds. We have plus 4x minus 2. And then that is all over. Now put the denominator back. All over x plus 2, x plus 3. You'd say, there's my answer. I just need to see if my answer simplifies. So you'd say, how do I simplify it? I factor the top, factor the bottom. Pull out a 2, then left is x squared plus 2x minus 1. We need to check to see if this quadratic factors. Well, multiplies to be negative 1 and adds up to be 2. Nothing, right? How are we going to make it negative 1? You guys see? So it doesn't factor, so nothing would divide out. So x cannot equal negative 2 and negative 5, and then nothing did end up dividing out in this one. Okay, first step is to factor out the denominators. We don't know what's in common unless the denominators are factored. Do not factor out numerators. So let's hurry and factor this. What multiplies to be negative 8 and adds up to be 2. 4 times 2? Negative 2. Quick factoring, yes. Rewrite your problem somewhere. So you have x minus 1 over the factors of x plus 4 and x minus 2. Are we all good? Now we're factoring this. What multiplies to be negative 16 and adds up to be 0? Yep, good. 4 and 4 and one of them would be negative. Awesome, you were right there. X minus 1 and then x plus 4, x minus 4 because we can quick factor. Now you'd say my next step is to get a common denominator. So look, x plus 4, check. X minus 2, nope, I need it. Once again, two terms, you need parentheses. Okay, this one needs an x minus 4, doesn't it? Next step is to multiply out the numerator only. So distributing this stuff in my head here, we have an x squared. We have a minus x minus 4x, which would be minus 5x's, plus 4. Then I have a plus sign. I'm distributing this, so I'm going to have an x squared minus 2x minus 1x, so that's minus 3x, and then we have plus 2. Combine like terms. 2x squared minus 8x's plus 6. All over our common denominator of x minus 4, x plus 4, x minus 2. You'd say, that's my answer. Now I need to see if it factors. So shouldn't I pull out a 2 so that I can quick factor? Yeah. So the first thing I'm going to do is pull out the greatest common factor of a 2. So it would be x squared
minus 4x plus 3.
Okay, awesome. So then let's factor that part. Please, please. Why me? Why is this happening? 2x squared minus 4x plus 3. Factor that bad boy now. What would that factor to be? So you said x, and then x minus 1. That's what you're saying?
Yeah.
X minus 4, x plus 4, and then x minus 2. Restrict first, then divide. X cannot equal 4, negative 4, or 2, and then divide out exact factors. Uh-oh. Nothing divides out, so that's our answer. We had to factor it though. What if we would have not? Might not have known what divided out. You know, just all that pain and suffering for nothing dividing out. Okay, awesome. I think we're getting the picture here for the most part. So I just want to see what you do with subtraction. So what would I do if it was me?
Move the negative to the top.
Then I would factor the denominators, correct?
Yes.
I get a common denominator, multiply out the numerator, combine like terms, right?
Yes.
And then we get the picture. This is my last example, then I'm going to let you go for it. So it says simplify. So once again, I say, oh, subtraction. I'm going to make that negative and a positive. I'm going to distribute my negative. So then you'd say, the first step is to factor out our denominators. So this would factor to be x plus 3, x minus 3, wouldn't it? Yes. And you'd say, I need my denominators to be the same. So doesn't this one need an x minus 3? Yes. Then this one needs an x plus 3. Use parentheses around two terms. So then the next step is to multiply out the numerator. 6, we didn't have to do anything to 6. There's a plus sign. Then we distribute this stuff out and we would get x squared plus 1x minus 3x. That's minus 2x. And then we'd have minus 3. Then we have a plus sign. Then we have a negative x squared. We have minus 3x, don't we? Plus 2x, which would have been minus 1x, and then it looks like plus 6. So then you'd say combine like terms. My x squareds are gone. So then I have negative 3x's, and then I have plus 9. And that's all over x plus 3, x minus 3. You'd say that's my answer, now I just simplify. We simplify by factoring the top, factoring the bottom, which would already be factored, restrict first, then divide. So x cannot equal negative 3 or 3, then we can divide out exact factors. So there's our answer. Okay, so if you follow those steps every time, it will work. You gotta be careful though. You can't make little errors with distributing negatives and whatnot. Okay, I know you guys can do it. So go start practicing some of those on the homework, evens or odds, the same theme throughout this entire thing. Go start doing some of the harder looking ones. So you can start out with 1 or 2 basics and then go pick some hard looking ones. And if you can do the hard ones, you can do the easy ones. We have to move on shortly here. So start practicing. Okay, so we've got to be getting really good at algebra and simplifying stuff because we've got to be good at that going on to calculus. So it says complex fractions just means there's a lot of stuff going on. There's fractions within fractions. So for example, right here I have this 3 divided by y minus 1 and then divided by 9y minus 1. There's a lot of stuff going on. There's 2 terms here and then there's 2 terms here. Now, we want, this is what our goal is. We want there to be a fraction with only 1 term on top. So the first thing we would do is we would want to fix this to be only 1 term, meaning get a common denominator and simplify. Does that make sense, everyone? Then there will only be 1 term if we put it together. And then we'd want there to be only 1 term on bottom. So we would need to get a common denominator on bottom and put it together so that it's 1 fraction. Because you can't use the rule, dividing fractions as easy as pi, flip the second and multiply, unless there's only 1 fraction divided by 1 fraction. You can't use that rule unless it's only 1 fraction divided by 1 fraction. So we basically just simplify it in sections. It's multiple problems within one. It's a division problem and it's an addition problem. You guys see what I'm saying? So you just keep your work separated. You say, okay, I'm going to do the top first. So the top is 3 over y. Now watch. People always get thrown off with this. Don't. It's minus 1 over 1. That's what it is. So our first step when adding fractions is get a common denominator. So we times by y over y, wouldn't we? Next step is to multiply out the numerator. So that'd be 3 minus 1 times y is y. So then that's the top, isn't it? But I would write it in standard form. So that's negative y plus 3 all over the common denominator of y. So there's our top. That's simplified. So I'm not asking you to factor it quite yet. So now we'll do the bottom. You would just show your work. On bottom, that's 9 over y minus 1 over 1. So then we get a common denominator times by y over y. So then that would be 9 minus y over y, which in standard form would be negative y plus 9 over y. That's our bottom. So I'm just going to keep your eyeballs because there's a lot of stuff going on. That was the top. That was the bottom. So now you would just put it together. You'd say, so I'm dealing with this. Negative y plus 3 over y divided by negative y plus 9 over y. And now because we have 1 fraction on top and on bottom, we can do dividing fractions as easy as pi, flip the second fraction, and multiply. Now how do we multiply? Keep the rule separated in your head. Isn't the first step in multiplying factor all the parts?
Yes.
Okay, awesome. I need room to write real quick. So, real quick, let me erase this and then we'll keep going. So factor the top. What would you get? We wouldn't multiply it, right? That's the one major rule to not do, remember? Multiply, but don't actually multiply, right? So we're at our first step of factor all the parts. How would you factor that, people? Then we have a y minus 3, don't we? And then we have times by y, but we don't actually multiply them, do we? That's on top. I just multiply and have the top all factored. Now on bottom, I have a y, great. I have a lot of negative 1. And then left would be y minus 9. I just put the negative 1 in front of the y. Does that matter? No, because multiplication can be reordered. Okay, now restrict first, then divide. Y. Oh, well, you know what? We're not going to restrict with complex fractions. We don't have time, and I'm not going to ask you to do it on the test. So just simplify from here. So negative 1's divide out, don't they? And the y's divide out. So your final answer, this big nasty problem, which wasn't that bad, simplified to be y minus 3 over y minus 9. So it's not that we're learning anything new, it's just doing 2 problems within one. Kind of 3 problems within one, honestly. Okay, let's do another one. We're going to do problem now and even. 10. So it's multiple problems, like 3 problems within one. Here's problem, you'd say, okay, I need to have only 1 fraction. So let's worry about getting a common denominator on the top. That's over 1. I'm just doing the top here. So I'd multiply by a plus 1, wouldn't I? And a plus 1. Your next step is to multiply out the numerator and combine like terms. So we have an A. We're going to distribute negative 1 through to both. Make sure you distribute the negative 1 through to both. So then we have minus A, minus 1. Combine like terms. That's negative 1 over the common denominator of A plus 1. Okay, now just remember that was the on top. We'll come back to that in a minute. Now we're doing the bottom. You'd say, so we have A plus 3 over A minus 2 over 1. Then you get a common denominator. Times by A over A. So our numerator is A plus 3 minus 2A. So wouldn't that be negative A plus 3? All over A. So that's what's on bottom. So now rewrite your new problem. On top we have this, negative 1 over A plus 1 divided by negative A plus 3 over A. And now we're on to our third problem. Dividing fractions is easy as pie. Flip the second and multiply. So times by A over negative A plus 3. Then you would say to yourself, when multiplying fractions, I factor all the parts. So factoring all the parts, I would say, well, this is factored. All good there. Times by A, I need to pull out negative 1, and then left is A minus 3. Multiply straight across, but don't actually multiply. So I have negative 1 and A on top. I have an A plus 1, I have a negative 1, and I have an A minus 3. Then divide out exact factors. Isn't that it?
Yep.
So then it would be answer A over A plus 1, A minus 3. So it's not that it's hard necessarily, it's hard because there's a lot of room to make error. You're not going to know where if you get the wrong answer. So you just have to kind of go back and start kind of over again. Okay, let's do another one. They're going to get a teeny bit more advanced. Not that it's anything different, it's just bigger problems. So looking at this one, it's 23. You'd say, okay, a lot of stuff going on here. I can't flip and multiply. I can't divide by flip and multiply unless there's only one fraction. Right here I have 2. So let's just focus on the top. Let's get a least common denominator. So because the denominator is already factored. So this one looks like it's going to need an x minus 1. An x minus 1. Also, personally, I'm going to go like this. Plus, minus, plus. Do you guys see? So then I'm going to have that. This one needs an x minus 3. This one needs an x minus 3. And then parentheses. The next step is to multiply out and combine like terms in just the numerator. So we have a 2x squared. We have minus 6x plus 1x. Wouldn't that be minus 5x? Then we have minus 3. Then I have this plus sign right here. So I have a plus sign. I'm distributing this. That's a negative x squared. Then I have plus x, that's plus 2 x's. And then we have minus 1. So combining like terms. So we have 1x squared. We have minus 3x minus 4. And this is just the top all over the common denominator of x minus 1 and x minus 3. So that's our top. Now our bottom is already just one fraction. Isn't that x squared minus 3x minus 4 over 1? So dividing fractions is easy as pie. Flip the second fraction and multiply. So now we're going to times by our second fraction flip. So 1 over x squared minus 3x minus 4. Now normally when multiplying we factor all the parts, right? But do you see how I'm not even going to worry about factoring these because I don't think it's the same? So they'll divide out when they factor anyways, right? If I'm not asking you to restrict, you don't need to factor. Otherwise you would still factor it because you need another restriction. So what? We multiply straight across but don't actually multiply. So then this divides out with this. So left is 1 over x minus 1 and x minus 3. Another one, just because it comes with practice. Right. And this is when math starts, I was telling first hour, this is when math starts feeling good. Math is not, you don't feel good when you can do an easy problem. Who cares if you can do an easy problem, right? What if you do? It's when you start looking at these advanced ones and you know it's hard and you're going through and then you look at the answer and then it's right. That's when you start getting the warm fuzzy feelings. That's when math starts becoming actually fun. Yeah, it's hard, but that's what makes it fun. That's when you finally get fulfillment. Okay, everyone, look at 28. So, focusing in sections. So you'd say I need to get a common denominator. We're just focusing right here. So wouldn't I need to multiply by m plus 3? M plus 3. Then I throw in parentheses around that. This needs an m minus 3. I'm going to distribute my negatives, so I'm going to hurry and change colors here. That's a plus sign, then that's a minus sign, then that's a plus sign. Okay, and then m minus 3. So multiplying out the numerator here. So we would have m squared plus 3m, so that's plus 6m's. And then we have plus 9. Then we have a plus sign, distributing out this, so that's negative m squared. Then we have a plus 3m, so that's plus 6m's. And then we have plus, minus 9, or is that plus 9? Minus 9. Whoa, last hour they said it was plus 9. I remember them specifically saying that. We got 18. Okay. Right? We've done it right? Yep. Okay, awesome. Moving on. Combine like terms. So look, our m squareds are gone. We have 12m's, don't we? And our 9's are gone. So we have 12m over the common denominator of m minus 3, m plus 3. Now on bottom, we've got to do the same thing. You'd get a common denominator. So m plus 3. Oh, maybe this is where it was. I bet this is where it was. M minus 3. So I'm just confused on which part we were doing. So then when distributing this out, I'm going to keep my work separated. We have an m squared plus 6m plus 9. Then we have a plus sign. Then we have an m squared. Then we have a minus 6m plus 9. Don't we? So combine like terms. That's 2m squareds. My 6m's are gone. And then plus 18. This is where it was. And then that's all over m plus 3, m minus 3. Is anyone lost? We've just simplified the top. We've just simplified the bottom. Now can we do dividing fractions as easy as pi, flip a second, and multiply? Okay, so then we have this. Changing. Click. Doing good. So we have 12m. m minus 3m plus 3. Then we have a times sign. We have an m plus 3, m minus 3. Then we have on bottom, we'll pull out a 2. I'm going to factor it while I flip it. Pull out a 2, then left is m squared plus 9, which does not factor. So now we can divide out exact factors. Because multiply straight across, but don't actually multiply. Is anyone mad if I don't rewrite it? People last hour were confused when I wasn't rewriting it. Just pretend like we multiply straight across. Scoot it 12m over if you need to in your head. That's all I'm doing, right? Okay, so we can divide out 12 and 2. So that becomes a 6, doesn't it? M and any other m's? No. M plus 3, m minus 3's. So left on top was a 6m. On bottom was m squared plus 9. Would I divide across addition signs? No. That's my answer. Are you guys seeing how to do these? Are you feeling like you could do them by yourself? Or just bigger, harder problems? Okay, awesome. Before we move on to negative exponents, I'll show you what I mean in a second. I want you to go practice some of that caliber. So go to 2-3 continued, and you're doing every other even or odd. Before we learn this, just talk about negative exponents. Don't do anything with a negative exponent yet. So like 32, don't do anything of that caliber quite yet. Do it. Yeah, that's why we're going to review it first. So everybody look. Negative exponents are not appropriate. It is not okay to have a negative exponent. It's not considered simplified. Well, how do we make it a positive exponent? We take it, we draw a fraction, we flip our base over the fraction. So that would be x squared on bottom. Now it's positive. What would be on top? So we'd have 1 over x squared. They are equivalent. That's equivalent to x to the negative 2. This one's a better way of writing it. So right here, we have a negative exponent on bottom. Take the base, flip it. So this is equivalent to 2x cubed. Does everybody see? So what would this be? Where would I flip? X squared down to the bottom, wouldn't I? And then a y cubed down to the bottom. And then z to the, that's a negative 1. It's just all jumbled together. So wouldn't I have a z to the 1 on top? Do you remember how this rule works? Okay, awesome. So, we do have to look at 32 and look at the difference between these two problems. Okay, look. Look at the difference between this problem. It's 2x to the negative 1 plus sign 2y to the negative 1 divided by x y to the negative 1 minus x to the negative 1y. Now look, there's a difference between having addition signs, subtraction signs, and multiplication signs. This one, we could, with multiplication, you can just take your base and flip it up over the big fraction here. So with this big fraction, we can take x to the first down, leaving me with 2 on top, this 2. We now have an x on bottom from that. We have a 2 on top still, and then I'd bring the y down to the bottom. Now right here we have an x, it wasn't negative, so we have another x on bottom. We have a y to the negative 1, that'd be y on top. x on top, wouldn't it? Because this would go up. And then y on bottom. So that would have been 4xy over x squared y squared, and then we could simplify it. We can't do that with this problem. Here's why. So this big line right here, you can't take x and flip it because it had an addition sign. These are connected. Do you guys see what I'm saying? So you can't flip it across an addition sign. However, we still have to fix it. We can't have negative exponents. So this is how you fix it. Fix it over itself. So just say, I'm going to fix this right here. So wouldn't we take our base and flip it? Like we just saw in the last example. So just that piece, yes, is 2 over x. Then we still have our plus sign. Now just fix this piece. Flip that down so it would be 2 over y. Then we have our big division sign. Now we got to flip, we can't flip it up because that's a subtraction sign, but we can flip it down here. So then we'd have x over y. Minus, we take this, flip this base down, so y is on top and x is on bottom. And now it's just dealing with the same type of problem we just saw. Okay, so then we would say, okay, let's get a common denominator right here. So we times by y over y, x over x. So on top here would be 2y plus 2x over xy, or yx. On bottom, we'd go x and x, y and y. So then this would become x squared minus y squared over xy. Now what's the rule? Dividing fractions is easy as pie, flip a second and multiply. So, I am going to be multiplying by, this is going to wig out for about 5 minutes, because I went ham sandwich on it. Okay. Okay. Right here. Okay, I'm going to just factor as we go too, because we're going to times by and then this will be on top, right? So now our next step is to factor. We'll pull out a 2. Then left would be y plus x. Then on bottom we have a yx. Right here we have a times sign. We have a xy. Then right here, how do we factor 2 perfect squares? How do you factor x squared minus 9? No, this is 2 perfect squares, not to be confused with 2 perfect cubes. So x plus 3x minus 3, they would need to be conjugates, correct? Middle term canceled out. So how would we factor x squared minus y squared? Yep, and x minus y, or not y minus x, that's not the same thing. So x minus y. Now, multiply straight across, but don't actually multiply. I'm just going to extend my line and know that there's multiplication signs. Same thing. Divide, divide. Anything else? And then left on top was a 2, on bottom a x minus y. Okay, do you think you can fix negative exponents appropriately now? Go find one with a negative exponent right now and do it so that you can make sure you're good. Even if you're like, well, I'm doing every other odd and that's not part of it. You're going to have one on the test, so pick one and do it. Yeah. 2-3 continued. You're going to do 9 through 37 evens or every other even, right? Every other odd except for negative ones. I would do everything with a negative exponent. How many are there? Oh, you're working on the odd. Where else is it? I'd at least do, and didn't I do one of them? I would pick at least 3 negative exponents and make sure you're good at them. That's just me though.